Let's talk about Form 4, since that's where we are. Uh, okay, we're starting on question 1. It's a music website that keeps track of downloaded music. We have a download info object that has these methods that we don't get to see the implementation of, but we do know what they return, right? And we do know what they take in as parameters, what we need to feed them, right? Same thing, we have a music downloads object, and this class has methods that we're going to write. So what it does is it returns a reference to a download info object with a title that matches the parameter title. So this is almost exactly like your the toy store lab that we did. This is the equivalent of get that toy. So part A is about exactly like the get that toy method. So we're gonna remember this one. You just need to remember that you have a download info object. You got to remember you have a download info object, and that it takes the parameter title, and it has get title. I think I spelled title right. And then it has this other method called increment times downloaded. Okay, we need to keep track of that. So it's going to, where do we go here? Okay, so first to an instance of music download table below. So it looks through a list like this, and it would say like how many times is song with whatever title been downloaded, or and if it's already on the list, it returns the object. If it's not already on the list, it returns null. So we have to also remember that we have this list, which is a list of our download info objects. So we have this list of download info objects. Whoa. Let's try that again. List of download info objects. And so we're going to loop through the list. If the object title is in the list, we're going to return the object. Otherwise, we're going to return null. Okay, so how does that look? Well, take a look here. So we have, I think the first thing it wants us to do is, yeah, so we're getting the download info, right? So for each download info object in our download list, right? So for each of those objects, we're going to run get title on it. And if that title is equal to the title that we're putting in, then we return the object. Otherwise, we return null. So it's just like get that toy. Okay? Part B is going to look a little different. Remember that you have that get download info, so I would keep it written down, right? So I'd say get download info And I would remember that returns null if not on the list. And it returns object if is on the list. Everybody with me so far? Are you guys, do you guys see my screen?
Yeah.
Okay. All right. So we know we have that, right? So we're going to use that to do part B, which is they want to write the music downloads, and it looks through the list of downloads to see if something's been downloaded before. And if it has been downloaded before, it would show up on the download list, right? But if it hasn't, we have to add it to the list. So if it's on the list, so here's what we're doing essentially if you read through it. If it's on the list, add 1 to that one to the number of downloads. Else add the object to the list. Okay, so this one, again, it works just like the toy store thing for the most part. We have update download methods. We're going to take in a string of titles. We're going to loop through the string of titles, right? We're going to set one. We're going to take the current title, right? And we're going to make a download info object from it. And the way we do that is we're going to get download info. So we're going to use this method to see if it's on the list, right? If it's null, we know we have to add it to the list. Okay, because if get download info returns null, that means it's not on the list. Otherwise, we're going to use we have this increment times downloaded method, right? We don't get to see the implementation of it, but we know what it does and that it's there, right? So if the item's already on the list, then we already have an object that we can just increment the number of times downloaded using that method. Seems pretty straightforward if you had a good understanding of what you were doing when you did that lab. What lab was that? Was that like 6.4? Something like that? Do I have questions on question 1? Okay. Please let me know. Question number 2. This one's relatively easy. I think all we had to do is write like a class in one of the methods, right? So we have a set of classes. Item interface just means you have to have a purchase price, right? So if you implement an item, you have to just return a purchase price. Oops. So that's all you do, and that's in double form. There's our abstract class. That's a taxable item, which implements the interface. So a taxable item, the only big thing is that we have a list price, right? List price. Okay, so we need a list price, And that's usually, we'll go over what that is. We're going to implement that one later, I believe. But anything that extends taxable item, you know that it has to contain that method that returns a double, right? The big part of taxable item is the tax rate. So when you create taxable item, tax rate when you create, okay? So anytime you're creating a taxable item, you know you have to include a tax rate. So now it's going to make us write the taxable item method purchase price. Purchase price of a taxable item is just the price plus the tax on the item. Tax is computed by multiplying the list price by the tax rate. Okay, so essentially, we're doing this. Sounds super complicated. It is not. For the list price, right? Because remember that it's equal to the list price by the tax rate. So we're returning the list price plus the amount of taxes, basically. I would not return and set a new variable because we already are inheriting variables. Remember that the way the rubrics work on these questions is that if you write new code for a code that you already have, it's considered extraneous. That's where most of your point loss will come from. That and your algorithm not actually being functional.
It's just faster to like do it.
I don't know that it's necessarily faster. It's just more correct in terms of how the questions are structured. They want you to use get list price, right? And they want you to use the rate that you already have as a parameter and all that. So that was the easy part. Now we're going to create a vehicle class. So we're creating an entire class that has two parts to its list price: dealer cost and dealer markup, right? So remember, when we create a taxable item, that we have to override get list price, right? So basically, we're creating vehicle, right? And we know what the price consists of: cost and dealer markup, right? We need variables for those. We're going to take them in as a parameter. Why do we need rate here? Does anybody know why we need rate there? Okay, glad we talked about this then. We're extending taxable item. We need tax rate to pass to the super, because the super does not have a default constructor. It's expecting something to be passed in there for rate. So we take in rate, pass to the super, then we add everything else that we need in the constructor. Once we have that, get list price is easy. It's just cost plus markup. Do we need to, why don't we need to override get list price or purchase price? Correct. Purchase price doesn't need to be overwritten because it's already inherited, right? And it's already, so it's already calling get list price, which in our context does the correct thing, and then adding the tax break. It's already perfect just the way it is. doesn't need to be modified for this particular glass. So if it doesn't need modification, we don't include it in there. That's probably the only place to really lose points on this question is by adding in purchase price and overriding it and basically coding too much. So whatever you do, no matter what else you screw up, that's probably the one thing you don't want to do is override purchase price. Okay? Let me know if you have questions on that one too. Number 3, give you an incomplete customer class, stores information about a customer. So we have get name, get ID, and this is going to be a compare customer. So what do I want to say about compare? So compare customer's job is to take 2 customers and compare them what they call lexicographically. That just means let's find out which one would come first in the dictionary if they were both actual words, right? So it starts to order them by name. But if 2 names are the exact same, then it orders them by ID number. So for instance, if one customer has a name that would come, or if 2 customers have the exact same name, right? Then the algorithm would go down and compare the IDs to see which one of those is higher, to see which order to put it back into the list. So let's see how that works. Oh, the other thing that this is going to do is it's going to return. Is this one going to return changes? Yeah, so basically this is just going to check to see which one comes first lexicographically. So that's what we're writing first. So we're writing compare customer, and it returns a positive integer if the current customer comes lexicographically before the other input customer. If the current number would come after the input customer in the dictionary, it's going to return a positive number. Okay, so positive forward, negative backward in dictionary order. So all we have to do is this guy right here. So diff, you can use the compare to method. Basically, and I think that they give you that. Here, I think they give you some string objects. Yeah, so you get compare to here. So if you want to refresh what it actually does, you can do that. Let's go back to 3. So we are here. So basically we go, we set a difference value, right? And that's going to be positive or negative depending on what we get back from the comparison here. If diff is 0, meaning if the difference is 0 between the 2, that means they're the same name. So then we're going to check by ID. Well, it's pretty easy to just say, hey, I'm going to subtract one ID from the other, and whatever I get from there, that's what I'm going to return as diff, right? Because if you think about it, if that ID would come later in the dictionary than the other one, right? It's going to return a negative number, right? In the other situation, it's going to return a positive. So that sets us up pretty well. I think these should be actually, I want to say reversed, right? Because we want it to be negative if the other one's before. So that would actually return negative if get ID comes before the other, right? If our get ID comes before the other one, then that number would turn out to be negative. So that's actually the better order for that. Questions on how that works? Okay, so the tricky part comes down when they want to merge the two lists into one list called result. The example's a little tricky because there's not enough spots in results to contain all the unique names that are in the two lists. But even still, it works kind of the same way. So I have a list here, two lists here, and I'm going to want to fill a third list with all the names that are unique in the previous two lists. And they call it prefix merge. So you don't want to create anything that they didn't tell you to create. All the variables that you need should be created right there is all that's saying. So I want to go over the solution with you because it's a little bit tricky, but I think kind of at the same time pretty easy to understand once you get the hang of it. So I'm going to do, let's see, no, I want to do that. Oh boy. All right, there we go. Oh, I did it. All right. Okay, so since I have three lists, how many iterators am I going to need? Three lists. If I'm looping, I'm using three iterators because I have to loop through three lists. So there's a couple different ways to do this algorithm. I strongly believe this is the simplest way. I start with my first two iterators, set them both to 0, and then I also set my third one to 0, right? I and j. So I'm going to set I to go through list 1. I'm going to set j to go through list 2, right? And then the for loop should be the size of the smallest loop, which is in this case probably going to be the length of result. We kind of know at the very least that result is going to be the smallest because it's going to take all the names and merge all the ones that have the same name, right? So if somebody has the same name and ID in two different lists, that's the same customer, right? So we want to merge that into one value. So what we're going to do is loop through all of result. We're going to start everything at 0. We're going to check the value at list at I, or list 1 at I and list 2 at j, which are at this point both 0. So first values in both, we're going to compare them, right? Because we have that compare customer method. So we're going to compare C1 to C2. If we get a negative number, that means that C1 comes before and it's going to get added to the list before. We only want to go forward on the list that we're taking the value from. That's where this I++ is. Because essentially, if I'm taking from C1, I want to move its iterator forward, but not C2's. The reason is if I didn't use anything from C2, I want to keep that index in the same place because I haven't used that one yet. I only want to move past the values that I've used. That way I make sure I get all the unique values into the new array. So again, else if diff is greater than 0, that means that the value in C2 was comes before, right? So I want to add that to my result array before C1 and move j forward 1, so I'm moving forward in that array. If they are the same, right? So meaning if I run compare to customer, remember what that looks like. If I get a number of 0 from this, that means that customer has the exact same name and ID, which means it's the same customer. So what do? I pick one, right? I can return the one from either C1 or C2 because they're exactly the same. And then I move both iterators forward because we're at a spot in both where we have a name we need to eliminate. We've used it already. And then we're all set. Does have questions on that one? All right, that takes care of question 3. Last one's actually kind of simple by comparison to the others. Menu at lunch counter has salads, sandwiches, salads, and drinks. And they all have a name and a price that gets returned from a method. So any menu item is going to have get name and get price. So now we're going to do the relationship between all the items is pretty simple. But now we want to create a new trio menu item. And the trio is a combination of 3 items that results in a discount. Okay, so the way it works is we take in parameters of salad. We take in a salad, actually, is it sandwich salad drink? Sandwich salad drink. Drink. Okay. So we take in those parameters. We find which one has the lowest price, and then we subtract that price from the final total. Everybody with me so far? Sounds like not that hard, and it really isn't. What they want us to do, though, is write the complete trio class. So what do we need? Well, we need instance variables and parameters, right? So I'm going to just copy this in there. Oh, come on. Google Docs needs to up their game in terms of mouse selection. It's pretty small ball. All right. So we got sandwich salad drink as parameters, right? Taking the parameters, set the instance variables up. Then we have all of our menu items have to implement get name. So we're returning names of everything. Since these are objects, we can just run get name on all 3, concatenate everything together, and then we can return trio because it's a trio item, right? If you miss trio there or you get the naming wrong, probably not going to take points off. I don't really care. You know, that's all stuff we can do later once we get the big stuff working. Get price is pretty mandatory, right? That's the most important part. Here's what we need to understand. We need to get the prices of all 3. It's much easier if you put them into variables. You can do math.min. You can use that. I'm not sure if it's in the appendix. Doesn't give you math.min. That's a shame because it lets you, but you can use it. The general rule is you can use it, but you won't need it to solve most of these, right? Because we could find the smallest, which we've actually done before. We can just go if price 1 less than price 2.
We lose points if we get that. Like that's supposed to
If price, hang on, price 2 less than price 3. No, you would not lose points for doing it because it still works and it's not rewriting existing code.
but it's like small amount.
Now it's just not using specific language specific features of Java. This is actually the way they intended you to write it because math.min is a specific language feature of Java. It's not a general programming principle. And this is, in fact, probably mostly how it worked. So if that, return, else, or not return, min equals price 2, else min equals price 3. Else if price 2 price price 2 else min is price 1, sorry, price 3 price 2 min equals price 2, price 1, sorry, price 1 less than price 3 min equals price 1, otherwise min equals price 3. There you go. Else, I think this one either way, price 2 is less than price 3, min equals price 2, else min equals price 3. Yeah, something like that. So you just series of if statements, make sure it works. Otherwise, you can use math.min. Either way is fine. But now you just add all 3 together and subtract the smallest, right? You could go if this and that, then price equals price 1 plus price 2 only, or something like that. But that's a little bit more verbose. I would probably just subtract the number of the smallest at the end. That gives us the most leeway in terms of how complicated our algorithm gets. Do I have questions on that one? I feel like number 4 was like pretty easy. So that's it for question 4 or for form 4.